Okay, the last one exercise. Yes, the last one exercise concerning those micro galvanic cells. Yes, in other words, the metals displacement from electrolyte solution. Yes, because those are the same meanings. Yes, micro galvanic cells and metal displacements from the electrolyte solution by the other metal. Yes. So the last one exercise, please arrange the metals involved in the given reactions in order of decreasing reducing power. What does it mean? What does it mean, the reducing power phrase? Yes? Okay, so as you could see previously, the reducing power means if some metal standard potential is very low, the force to undergo for this metal, yes, the force to undergo oxidation reaction is much more higher, yes. So if the metal has a lower potential, as low as it is possible, the reaction, oxidation reaction of this metal, yes, proceeds faster, yes. So this metal which undergoes oxidation reaction force another component to undergo reduction reaction. So the reducing power of such a metal with lower standard potential included in the half cell with this metal, yes, is much more higher. I mean this reducing power. So we have four different reactions, yes, with metals or compounds in which those metals are included, yes. We have four different overall reactions and four different metals, atoms, and metal cations. We have thallium, we have thallium, we have molybdenum, we have cobalt, and we have palladium, yes. And we have to check the reducing power of these metals, yes. So firstly, let's write an arrow, yes. Let's write an arrow here. On the right side of this arrow, we will place the most noble metals, yes. On the left side, the most active. What does it mean? The most active means with very low standard potential of the half cells, yes? Very low standard potential means that those metals will undergo much more easily oxidation reactions. Noble metals with higher standard potential. What does it mean? That this means that the more active metals, yes, has a much more higher reducing power. Noble metals has much more lower reducing power, yes. Okay, so let's check the first one reaction. We have a thallium with the oxidation state equal to 0. We have, of course, as a substrate, yes, and we have, of course, the compound in which the molybdenum oxidation state is equal to +3. So in this compound, in this salt, we have molybdenum cations. In the solid, I mean in this case, in the electrolyte solution, we have the molybdenum cations with the charge equal to +3. And what happens? Thallium is oxidized to the cations with the oxidation state equal to +1, and molybdenum is reduced to the form of the metallic state.